Good morning. I want to start the day with talking about the basic graphs worksheet, which was your homework worksheet from last night. So if you could take that out for me right now so that we can talk about one of the questions from that worksheet. Remember you were given an answer sheet, and on that answer sheet has all of the answers from the worksheets from chapter P. So hopefully last night you did look over those answers as you were working through it and you made the corrections that you needed to in your other colored pen. Remember, if you get a problem wrong, we want to make sure that we're correcting it in a colored pen or something else. If you're using a blue pen, write it in a black pen, or if you're using a pencil, write it in a red pen. It needs to be in a different color, so it's pretty easy for us to see when we're using that as a study guide. So if you flip to the back of that page, number 15 is a word problem. And this word problem wants us to graph something in the calculator. So I want to talk about it so that everybody was confident about how to graph something in their calculator, changing the window. This problem talks about a manufacturing plant. They purchased a new molding machine for $225,000. It depreciates every year, and that value that it depreciates is the y. T is given by time, and that would be the number of years. So the equation says y equals 225,000 minus 20,000 t. And then the next thing right here are the constraints. That gives us the amount of time that this equipment is going to be purchased for. Probably the amount of time that it will last for. So it has 0 to 8 years, and that's important because those constraints are going to help us determine how to graph this in the calculator. So the first part, we want to use the constraints of the model to determine an appropriate viewing rectangle. That viewing rectangle is the part of the calculator screen that you can actually see. We want to make sure that the graph appears in that calculator screen, and all the important pieces of the graph appear. So you should see the x-intercept and the y-intercept. If there was a max or a min, we'd want to see the max or min. And then we want to give the window below. So if you hit the window button in your calculator, and that's at the top of your calculator, in there we have x min. We've got the x max, and then the x scale. So the x min is the first thing that we want to look at. And that would be up here because t is the independent variable and x is our independent variable. So our lowest value is 0. Now I'm going to go 1 below that just to make sure that I can catch everything. So I'm going to go to -1. The x max will be the largest t value, since again t is the independent variable, and that is 8. I'm going to just keep it at 10. You could go to 9, but again I'm trying to just make sure I catch everything that I need to see. So I'm going to go 1 or 2 above that. The last one is the scale. The scale would be the distance between your tick marks. Because -1 and 10 are so close together, we don't need to change that, so that means each tick mark would represent 1 unit. Now, if we look at our y values, the y min, the y max, and then the y scale. In order to determine that, we need to use the constraints that you are given. The easiest thing to do is just to take the 0 and the 8 and to plug them into the problem. So my first one, if I plug a 0 in, that's going to give me one of my y values, and in this case it's going to be 225,000. That's going to be the maximum y value because this is depreciating. So at 0 years, it's worth its most amount of money. At 8 years, it's worth its least amount of money. So my maximum value needs to at least be 225,000. And again, I'm going to go more than it, so I'm going to go up to 230,000. I know that is the max because it has to start at its maximum amount of money, and it's only going to depreciate from there. The minimum amount will eventually it would be worth 0. Again, you could also plug in the 8.
For an interruption, if you did.
So you could plug in the 8 if you wanted to and find out the exact value, which would be easy to do. Go for it, you can do that. Or you can use kind of common sense and say, well, the equipment isn't going to be worth anything after a certain amount of time. So you could use the y value of 0. If it's depreciating at some point, it's not going to be worth anything. So I will use -10 instead of 0 because I do want to get the x coordinate. So to go below that, I went down to -10. The last thing on here, the y scale. So this y scale again tells me the distance in between each tick marks. my numbers are fairly large. So when we want to do our y-scale, you need to make it a fairly large value. So you could do 1,000, you could do 10,000 if you'd like. But that'll kind of help your calculator screen and it'll get a better gauge of what your graph looks like. So I'm going to use 10,000. When you're graphing these, some of it's trial by error. So if you want to try 1,000, hit the graph, see what it looks like. Plug in 10,000, hit graph, and see how it changes the dimensions of your screen. So the next thing that you want to do is graph this in your calculator. You have all of the information. You should have the equation in. You don't need to plug in anything that deals with the constraints because we use the constraints in the window. So we have the information in, hit graph, and then you should definitely see the graph that accompanies this equation. So now that you've done that, maybe check to see with the person next to you that you've got the same graph. And if there are any questions further on this, feel free to ask me tomorrow morning during homeroom. So what we're going to do now is we are going to move on to our review, continue talking about these prerequisite topics. Factoring is one of the most important things that we will talk about, and we will use it in all years. So it's one of those concepts that you use continually in math. You learned it way back in Algebra 1, you reviewed it in geometry, and then you also did a really good review last year in Algebra 2. And now we're going to review it again, just so that you are fresh with those factoring skills, because we will use it in almost every section, and even in the trigonometry portion will be factored with trig terms like tangent and sine and cosine. So if you look in your prerequisite packet, it's page 5. See if you can turn to page 5 in the packet right now. So we want to talk about the 3 most common steps of factoring. The first thing that you always want to do is look to see if there is a greatest common factor. Is there something that you can take out of the problem? That has to be done first before you do any other kind of factoring. So look to see if they have something in common, the biggest value they have in common. The second thing says if it's a binomial. A binomial means it has 2 terms. And it's on the form a squared minus b squared. This is the difference of perfect squares, or the difference of 2 squares. That's factored by a pattern, and it's a special pattern where you have a minus b and a plus b. Now, the thing to remember is that it must be the difference. It cannot be the sum. So it does have to be a difference for it to work with this pattern. The last thing says if it's a trinomial, which means it has 3 terms. You can either use trial and error, which means that you can look at the problem and be able to kind of guess the numbers that work to factor it, FOIL it to make sure it checks out, or you can use the AC grouping method, and I think that's probably the most common method that everybody uses in here. And we'll make sure to go over that to refresh your memory. So if you look at the next 6 examples, the first one we have 27x to the 4th minus 12y squared. It has 2 terms, so we would want to try and think about the difference of 2 squares here. The other thing that we want to think about is it does have 2 terms, but maybe it has a greatest common factor. So if we look at 27 and 12, the biggest number that both of those have in common is a 3. Then look at your x term, your y term. They don't have anything in common. The first term and the second term have different variables. So the only thing we can take out is a 3. And then after we take out that 3, we want to continue factoring it. So we would end up with 9x to the 4th minus 4y squared. So that would be step 1. Factor it by taking out a greatest common factor. Now, the stuff inside, the terms inside here, that's still a binomial, so we can factor it even further. And this one factors by the difference of 2 squares, because 9 is a perfect square and 4 is a perfect square. And that pattern says a minus b, a plus b. So the square root of 9 is 3. The square root of x to the 4th is x squared. So my a term is 3x squared. My b term, I would take the square root of 4, which is 2, and then the square root of y squared is just y. So I have 3x squared minus 2y. And then finishing the pattern, you have that same 3x squared, but it's plus 2y. The last thing that we want to do is check to make sure that it's completely factored. So if you can factor it any further, you want to do that. And look at your terms. This first term is still a binomial, but 3 and 2 are no longer perfect squares. So that means I cannot factor it any further. even though it is a subtraction sign. The second one, again, it's a binomial, but it can't be factored any further. You've got a plus there. So this one is our finished answer. It is completely factored. So if we look at our second problem, we have a to the fourth minus b to the fourth. Again, it's a binomial. It doesn't have a greatest common factor because there's no numbers that they have in common and no variables. But it is a difference of two squares, so we want to try and factor it. And that follows the same a minus b, a plus b pattern. So a to the fourth, if I take the square root of that, it's a squared. B to the fourth would be b squared. And then I would have my a squared plus b squared. So I have the difference and then the sum following the pattern. So just like before, I've done the first step of factoring. I've used the binomial, difference of perfect squares. Now I want to check to make sure it's completely factored. And if I look at this first term, it is still a binomial. It still is the difference. And a squared is still a perfect square. So this first term here can be factored further. Again, you're going to take the square root of both of those two terms. So the square root of a squared is just a. The square root of b squared is b. So a minus b and then a plus b. The next term is a binomial, however, it's an addition sign. Since it's addition, it cannot be broken down any further, so it's going to remain a squared plus b squared. So now this is completely factored, a minus b, a plus b, and then a squared plus b squared. The next four problems use the either trial and error or the AC grouping method. The first one is pretty much a straightforward one. We have w squared plus 8w minus 20. The reason I say it's straightforward is because the first term doesn't have anything in front of it. The coefficient is just a 1. So when you're factoring it, you're looking at the negative 20, and you want to think of factors that make negative 20. So you could use 2 and 10. You could use 4 and 5. We want to combine those two values to get the 8 in the middle. So that would be a negative 2 and a positive 10. So when I factor it, this is very straightforward. It's just w minus 2 and w plus 10. There's nothing else to do factoring this because the coefficient in front of the w squared is a 1. So that's the basic AC grouping when you have a coefficient of 1. The next one is definitely a little more involved. We have 6x squared minus 89xy minus 15y squared. So first thing, is there a greatest common factor? The numbers are pretty large. Maybe there is one. 6 and 15 definitely have a greatest common factor. However, 89 does not. So there's not a greatest common factor. Looking at the AC method says if you don't have a coefficient of 1, then you want to take the first number times the last number, the A times the C. So we have 6 times negative 15, so that would be negative 90. Again, I want to come up with values that combine to be the middle number, and that middle number is 89. So there are a bunch of factors for 90. You could use 9 and 10. But 9 and 10 get us nowhere close to 89. My other option would be to use a 1 and a 90. And if I use 1 and 90, then I am going to get to 89. And it's a negative 89, so I want a positive 1 and a negative 90. Now, the AC grouping method says that you keep the first term the same, so I'm going to keep that as 6x squared. Then I use one of my factors, which is just a 1, and I have to have an xy in it. My middle term has an xy, so we would have an xy. If you want to put the 1 in front, you can, but you don't have to. And then I have negative 90. I'm using my second factor with the middle term, that is xy. So if I look here, 1xy minus 90xy, these two should combine to be that middle term, which is negative 89, and they do. And then the last term stays the same as 15y squared. Now, factoring by grouping, because it's the AC grouping method, so I did the AC part, I took A times C. Now we need to group the terms together. And we're going to group the first two and the last two. We want to pull out what they have in common. So if I look at 6x squared and 1xy, the only thing they have in common would be an x. So we'll pull out the x. You're left with 6x plus y. For the next one, we're going to do the same exact thing. Going to look to see what they have in common. We have a negative 90 and a negative 15. So I can pull out a negative 15. And then we have an xy and a y squared. And they also have a y. So we're going to pull out a negative 15 and a y. Negative 90 divided by negative 15 is 6. And then pulling out the y leaves me with 6x. Negative 15y squared divided by negative 15 just leaves me with a positive y. The last step of factoring by grouping is to make sure that your parentheses are the same. The quantity in the parentheses must be the same in order for you to factor by grouping. Because we're going to group the two terms in front of them, the x minus 15y together, because those are followed by the like term of 16x or 6x plus y. So since these are like terms, you can take the terms in front, the x and the negative 15y, and group them in one parenthesis. These are the like term parts, so that would follow down as the 6x plus y. So I would like you to look at the next problem, and I'm going to give you a couple of minutes to try it on your own. We have 3m squared minus 2mn minus 8n squared. The good thing about this problem is that the numbers are a lot smaller than the problem before. So I'll give you about a minute or two, see if you can get this one to factor on your own. Check with the person next to you to make sure that they have it correct and see if you can help them through the problem as well. I'm going to start working through this. If you're still working, that's fine, but I'm just going to start so that you make sure they've got it correct. A times C is negative 24. We're trying to combine to be a negative 2. There are a whole bunch of different options that could work to multiply to be 24. But 6 and 4 seem to be two good options that we could use. And if I want a negative 2, we would need a negative 6 and a positive 4. So then when I rewrite this, keeping the first term the same, and then I'm trying to get that middle term, which is mn negative 2mn. So negative 6mn plus 4mn, and then minus 8n squared. The last term stays the same. So when you're checking this, the middle two terms, 6mn, 4mn, when you combine them together, you should get negative 2mn. Now we group the first two terms and the last two terms, pull out what the first two terms have in common, which will be a 3m. So I have 2m, I would have m minus 2n. And then looking at the next one, they have a 2n in common, so I factor out a 2n. And when I factor out that positive 2n, make sure you put that positive in front. It needs to make sure that I've got two separate quantities there. I would have, a 4n. Let me start over with this. I'm taking a 4n out, and then I would have m minus 2n. My brain's working too fast for my hand today. My terms are the same because they have the parentheses in common, so they're like terms. I can finish grouping by taking 3m plus 4n, and then the m minus 2n. Hopefully you were able to factor that one fairly easily after we've done one together. The last one is our final factor by AC grouping method. And we have 9x to the fourth minus 13x squared plus 4. Don't let the powers scare you. Just because it's an x to the fourth doesn't mean you factor it any differently. It still is a trinomial, and anytime it's a trinomial, we're going to use that AC grouping method. So just like we did with the other ones, taking the 9 times the 4, and that gives me a 36, and it's a positive 36. So I'm going to try and make a negative 19. Well, 9 and 4 seem to be my options to get a negative 13. And they both have to be negative. So a negative 9 and a negative 4 make a negative 13, but multiply to be my positive 36 at the top. Now, when I do the AC grouping, my first term is 9x to the fourth. My middle term here is 13x squared. I can get 13x squared by negative 9x squared and negative 4x squared. So the only difference is that I now have an x squared in my middle two terms. In the previous problem, we had an m and an n. So whatever that middle term is, these must match your middle term. And then the last term is positive 4. So the two terms have to combine to be the negative 13x squared. Now we group the first two and the last two. Pull out what they have in common. So I would pull out a 9x squared. And then I would still have an x squared minus 1. My second term, I would pull out a negative 4. And when I do that, I have an x squared minus 1. So continue to factor, pulling what I have in common here. 9x squared minus 4 gets grouped together. And then x squared minus 1. So that would be the AC grouping method. If I look at the answer, you always have to ask yourself, is it factored completely? Can it be broken down any further? And if you check this problem here, 9x squared minus 4. 9 is a perfect square as well as 4, and it's a difference. So this is a difference of perfect squares. It's a binomial. It can be factored further. If I take the square root of both of these, I would end up with 3x minus 2 and 3x plus 2. My second quantity here in parentheses is x squared minus 1. It is also a perfect square because I can take the square root of x squared and I can take the square root of 1. So this becomes x minus 1 and x plus 1. Now if I look at my answer, I have 3x minus 2, no longer a perfect square. The 3x plus 2, the x minus 1, and the x plus 1. They're no longer perfect squares, so it cannot be factored any further. So this would be the entire factored solution. And it's factored completely. It's broken down as far as it can go. So these 6 examples are using greatest common factor, AC grouping, and the difference of two squares. If you flip over to the back of this page, there are 4 more types of problems that we're going to use, and we're going to factor by grouping with these problems. We're not using the AC method. We're just doing factor by grouping. So you're already starting with more than 3 terms. In this first set, it's kind of started for you a little bit. You notice that you have 2 quantities in parentheses. So I have a 3x squared, and then I have the y minus 2. Over here I have a minus, and then I have this 2 minus y. These 2 quantities in parentheses are really close to being the same. The only thing that's different is that I have a positive y in the first one, and a negative y in the second one. I have a negative 2 in the first one, and a positive 2 in the second one. So I'm going to make them the same by pulling out a negative 1 from this second parenthesis. So I'm keeping the first quantity the same, the y minus 2. But the second parenthesis here, if I pull out a negative, that means this 2 is becoming a negative 2. This y is becoming a positive y. And if I pull a negative out, my minus sign is a minus sign, but if I pull a negative out, it becomes a plus sign. So again, I had the opposite. I had a positive 2. By factoring a negative out, it's now a negative 2. I had a negative y by factoring out a negative, it's now a positive y, but it changes the sign in the front. So right here, this now makes a plus sign. The other thing I'm just going to reiterate, which I think you probably already know, but just to remind you, there is a 1 sitting in front of this parenthesis. So now that I'm looking here, I have y minus 2 and y minus 2. When you factor by grouping means that you have to have that parenthesis the same. Once they're the same, you can take the 3x squared in front of the first parenthesis and the positive 1 in front of the second and group them together. And then we have y minus 2. So that one was a little different because of the parentheses. It was kind of like started for you with factor by grouping. But that second parenthesis was slightly different, so we needed to factor out that negative 1 to make it the same. Factor by grouping, your quantities and parentheses must be the same in order for you to factor by grouping. So if you look at the second one, example number 8 says 3x squared plus 2x plus 3xy plus 2y. Factoring by grouping, you can group any two terms together that you want. You can keep it as is and just group the first two and group the second two. Or if you want to rewrite it and group two different terms together, that's okay as well. But in this case, I'm just going to keep it the same. And like we did with the AC grouping method, we're going to pull out what they have in common. So looking at the first two terms, they only have an x in common. That leaves me with the 3x plus 2. The second two terms only have a y in common, so I now have 3x plus 2. Factor by grouping, I think, is fairly straightforward because you know how to do the AC grouping method, and we're just not doing the AC part. We just are putting parentheses, pulling out what they have in common. So now we have x plus y, and then 3x plus 2. Now this problem is factored using factor by grouping. We have x plus y times 3x plus 2. So I'm going to give you a couple of minutes, minute and a half, 2 minutes to try example number 9. As you're working on that, again, check with your neighbors, see if they're factoring it correctly, and then I'll work through the problem with you. All right, so looking at this, grouping the first two and the last two together. Again, if you want to rewrite it and group two different terms together, you can, but this one you can keep the same as is. First one, they would have a y in common, or an x in common, and then I would have y minus 4. The second one has a negative 2, so pulling out the negative 2. I would have y minus 4. And then x minus 2, y minus 4. That one I think was fairly straightforward. Do a mental FOIL to make sure that you have the same as what we started with. So we have x minus 2 and y minus 4. The last one, of course, we have to have a challenge problem in here, and this last one is definitely a challenge problem. There is one typo that I want to make sure that you're noticing. The second term, you have 4x, but you need to change it to 4xy. That y term has to be there because there's a y squared in that third term, so we need that y in the middle term. If you look here, the factor by grouping doesn't always have to be two terms. You can factor it sometimes grouping 3 terms together, and that's what we're going to do with this problem. If I try to group the first 2 terms together and the last 2 terms together, there really isn't anything that you would have in common after you try and pull out something or factor those quantities together. So that's why just grouping 2 terms together doesn't work for this one. So instead, I'm going to group the first 3 terms together. And as I said, every problem, not every problem, but every section of notes, we want to try and have a challenge problem for you. This one is definitely the challenge problem. So if I look at x squared plus 4xy plus 4y squared, this is another special pattern that you talked about last year in Algebra 2. And that special pattern said a squared plus 2ab plus b squared equals a plus b quantity squared. So this is a trinomial, and it's called a perfect square trinomial. And if I look at what I have an x squared, which would be my a squared. The 4xy is my 2ab, because my a term is just x, and the b term is 2y. So my a is the first value, the b is the last value. And then b squared would be my 4y squared. So this is a perfect square trinomial. So we have a difference of two squares when it's a binomial. This one is a perfect square trinomial. So if I go to factor this, it factors as the quantity a plus b squared. So here is my x squared. That means a is just x, as we said above. My b is the 4y squared, which is just 2y. And then I take that and I square it. So perfect square trinomial is x plus 2y quantity squared. And then you still have that minus 9 lagging behind, and we don't want to forget about the minus 9. So far, we've talked about this being a special pattern. It's a perfect square trinomial. We factored it using the special pattern a plus b quantity squared. Now, if we look at our solution, this isn't factored completely, because factored completely means that you should have two quantities that are being multiplied together, or three quantities, or four quantities. But factoring means multiplication, and I need to have everything being multiplied together. This is not multiplication because there's a minus sign right here. So, not multiplication yet. We need to continue to factor it. To factor this, we have to look and see what's going on with these numbers. And there's something special happening here, because I have a quantity that is squared right here with the x plus 2y squared. That is the a squared. We have another quantity that is squared, and that would be my 9. So this 9 here is a square, a perfect square. The x plus 2y is a perfect square. Now I have to factor it using the difference of two squares. So we first use the trinomial perfect square. Now this is a binomial and it's a difference, so I still have a perfect square for the binomial. And that would follow with the pattern a minus b and a plus b. My a term, if I take the square root of that, my a term is x plus 2y. The b term is the square root of 9, and that's 3. So I'm going to try and factor this. It's a little more difficult than any of the ones that we've done. Got to have that challenge problem. So I would have a, which is x plus 2y, minus b, so that would be minus 3. And then I have a, again, x plus 2y, plus b, so that would be plus 3. So we factored it as a trinomial first, and that was just the first three terms. We left the negative 9 by itself. After we factored as a perfect square trinomial, we're still looking at the problem, noticing that it's an x plus 2y squared minus 9. That's a perfect square, but it's a binomial, and it's a difference of two squares. So we continue to factor it with the pattern a minus b, a plus b. So we've got x plus 2y minus 3 and x plus 2y plus 3. So that's the end of the lesson for today. If you look at the next page in your packet, you will see page 7. And then on the back of that, you should also have an answer sheet along with the problems on page 7. This is a factoring worksheet, so you're factoring using the different types of factoring that we just discussed. You'll have a factoring quiz next Tuesday. It's the first quiz of the start of the school year. If you have any questions, please feel free to stop by any time throughout today after 9 o'clock, or of course we've got homeroom together tomorrow. Have a good day.